The next section is inductive and deductive reasoning. We are trying to build a skill set so that we become more logical thinkers because we're going to be asked to, in the next few chapters, be able to prove why something is the way it is. So this whole section is about building those skills and logical thinking skills. So a conjecture is an unproven statement based off of observation. And we use inductive reasoning skills to look at a pattern and create a conjecture for a general case. So what does that mean? So this is an example of a general case. We have figure 1 with a half-drawn circle, a circle with a line through the middle. Half is drawn, half is not. Figure 2, we have a circle split into 4 sections with one pie shaded in. Figure 3 is split into 6 sections with one slice of the pie being shaded in. So we want to use inductive reasoning skills. So that means we're going to look at the figures and see if we can come up with a common pattern so that we can create figure number 4. And from there, we want to come up with a general rule for this specific case. So figure 1 has 2 slices. And one area is shaded in. Figure 4 has 4 slices. Figure 3 has 6 slices. And we have one shaded, one shaded, one shaded. So based off of this, we want to continue this pattern. So we went from 2 to 4 to 6. So I would think that figure 4 would have 8 slices. And then we went from one shaded, one shaded, one shaded. So figure 4 is also going to have one shaded. So for my figure, I'm going to have 8 slices of the pie. And they're supposed to be even, but I'm just doing the best I can. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8 slices. Then one of those slices needs to be shaded. Location is important. It looks as if they are trying to go on the left-hand side and on the upper half. So our inductive reasoning skills allowed us to look at a pattern, find commonalities, and create another figure based off of continuing that pattern. It is also part of inductive reasoning is creating a conjecture or putting that into words. So how I worded that was the number of pie slices increases by 2. So that's the first thing we found. 2, 4, 6, 8 slices. And you could have worded that differently. All right. One pie slice is shaded and at the 9 p.m. location of a clock. So that was my choice with how I worded it and how I wanted to describe it. How you describe it could be totally different. We're just making a conjecture in words that describes our thought process on how to get to the next figure. A counterexample is a specific case that proves a conjecture false. So let's say somebody made the conjecture that the sum of 2 numbers is always greater than the bigger of the 2 numbers. So let's just add together, since sum is addition, add together 2 numbers. So 2 plus 3 is equal to 5. What they're saying is that the sum is always going to be greater than the bigger of the 2 numbers. In this case, I didn't come up with a counterexample because 5 is bigger than 3. All right, so let's try, I'm going to try something else. Let's do 0 plus 4 is equal to 4. So the sum of 2 numbers is 4, and they're saying that should always be greater than the bigger number. Well, 4 is equal to 4. 4 is not greater than 4. Therefore, 0 plus 4 equals 4 would be a counterexample. Now, there are a ton of counterexamples that you could come up with to prove this conjecture false. You could have said -2 plus -3 equals -5. Then we're comparing -5 to -2. Well, the sum is -5, and that is not greater than the bigger of the two numbers of -2. So this would be a second counterexample to prove that the sum of two numbers is not always greater than the bigger of the two numbers. The last thing we're going to talk about is deductive reasoning. So inductive reasoning follows a specific example and you're trying to figure out a pattern. Deductive reasoning is when you're going to use facts and definitions in order to form a logical argument. So they want to know what conclusion can we make about a product, so the multiplying of an even number with any other number. So it's really important that we test some numbers. So I'm just going to pick the most basic even number of 2. So if I'm looking at 2 times 4, that's 8. 2 times 1 is 2. 2 times 0, 0. 2 times -5 is -10. 2 times -2 is -4. So I wanted to mix up my second number so that I was looking at a bunch of different values. So I wanted to pick an even number, an odd number, and 0. And then I wanted to do the same with a negative, an odd number that was negative and an even number that was negative. And we're trying to come up with one conjecture or one conclusion based off of the results. If I go through and look at my numbers, 8, 2, 0, -10, -4 are all even numbers. So no matter what multiplier I use when multiplying by an even number, my result is always an even number. So deductive reasoning wants us to build a logical thought process to show that whenever we multiply by an even number, we're going to get out an even number. And deductive reasoning means that we're going to use facts or definitions that we already know. So I'm going to start off by representing an even number by 2 times n. We know that this is going to be an even number because anything multiplied by 2 is going to be even. Then they are asking me to multiply this by any integer n. So I'm going to multiply 2n, so that's our even integer, times m, where m represents any any integer at all. M represents any number. It can be odd, it can be even, it can be negative, it can be positive, any number at all. So now I'm going to actually take the product. So I have 2n times n. So this is showing that we're multiplying 2 times a product. Therefore, that I can conclude that 2nm is even, because if we go back to our first statement, 2 multiplied by any number is even. So even when we multiply 2 by a product of numbers, we're going to get an even number.